Assalamu alaikum wa rahmatullah. Hi everyone. In this video we will be talking about question 4 FRQ for a grade 12 elite for term 3. So it says let R be the region in the first quadrant bounded by the graph of y equals 2x, the horizontal line y equals 6 and the y-axis as shown in the figure above. Now if we look at the graph and the answer key of this question, the function should not be 2x. So I want you to change this one. This is wrong. It should be y equals 2 square root of x, not 2x, 2 root of x. Okay? Now, region R is the base of a solid. Okay? For each y from 0 to 6, the cross section of the solid taken perpendicular to the y-axis is a rectangle. So let's highlight the key phrases here. Okay, cross section. So this is not the revolution method. This is the cross sectional method. Perpendicular to which axis? To the y-axis. The cross section is a rectangle and the height is 3 times the length of the base. Right? But do not evaluate an integral expression that gives the volume of the solid. Now, if you look at those two integrals used for square cross sections or rectangle cross sections. In this question we have a rectangle cross sections, so we will use this integral, but our integral should be written in terms of y because the question says perpendicular to the y-axis. The height is given in the problem and the width is given by or the length, the width doesn't matter, it's given by f minus g, right? So because we are using the integral in terms of y, we must isolate x here. So how do we do so? How do we isolate x here? We will divide by 2, right? So we've got y over 2 equals root of x. So we will raise both sides to the power of 2 to the power of 2. That gives x equals y squared over 4. So we isolated x. Now the volume is given by the integral. Now look at the graph. We will go from 0 all the way to this number, which is here. This is 6. So it's the integral from 0 to 6 of width times height or length times height. Now the length, which is perpendicular to the y-axis, it would be the function itself, but in terms of y. So this is going to be y squared over 4 times the height. The height is 3 times the length of the base. The length of the base is the same as the width or the length. So it's y squared over 4 dy. So the volume is given by the we can write the constant, the coefficient in front, which is 3 over 16 times the integral from 0 to 6 of y to the power of 4 dy. This is the answer of the first question. Moving on to the next question, we have a multiple question now. Just a minute. Question 2 says let f of x equals e to the power of 2x. Let R be the region in the first quadrant bounded by the graph of y equals f of x and the vertical line x equals 1 as shown in the figure above. Part A, write an equation for the line tangent to the graph of f at x equals 1. So immediately when we read equation for the line tangent or equation of the tangent line, we must write y minus y1 equals m x times x minus x1. We are writing this tangent line at which x value? We're writing it at x equals 1. So x1, we will replace it with 1. And what is the value of y when x is equal to 1? Well, it's given here, right? So it will be e to the power of 2. So y1 will be replaced with e to the power of 2. Now let's find m, which is the slope. Now we know that the slope is the same as the derivative of the function, right? So what do we do now? We will differentiate the function. So we need f prime of x, which is given by 2 times e to the power of 2x, and we need the slope of the tangent line at x equals 1. So we will substitute the 1, which will be 2 to the power of 2 multiplied by 1, which is 2 times e squared. This is going to be the slope. So the final answer will be y minus e squared equals the slope, which is 2e to the power of 2 bracket x minus 1. This is the equation of the tangent line. You can move this minus e squared to the other side, or you can keep it like this. Now part B says find the area R. To find the area R indicated in the first quadrant as shown in the figure, it's just the area under the curve of f from 0, from x equals 0 to x equals 1. So part B, the area is given by the integral from 0 to 1 f of x dx, يعني e to the power of 2x dx. Listen, this is just an area. There is no square, there is no pi, it is just the area, okay? The area under the curve. Now, what is the integral of e to the power of 2x? Well, the integral of e to the power of 2x is e to the power of 2x divided by 2. We used to multiply it by 2 in derivatives. In integral, we do the opposite. Evaluated from 0 to 1. Let's plug in the upper, e to the power of 2 times 1 over 2 minus e to the power of 2 multiplied by 0 over 2. This is equal to 1 over 2 e to the power of 2 minus 1 over 2. And if you factor out 1 over 2, you will get e to the power of 2 inside minus 1. This is the final answer. You can write it in decimals as well. I'm not using the calculator directly here because this is a non-calculator active question. So, okay, so if you look at part C, it says region R. Let's highlight what we have here. Region R forms the base of a solid whose cross sections perpendicular to the y-axis are squares. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. First of all, because this is perpendicular to the y-axis, we must isolate x. So let's look at the given function. The function is, let's replace f of x with y. We get y equals e to the power of 2x. You take ln of both sides. What's going to happen? We've got ln of y equals 2x. We will divide by 2. Divide by 2. That means x equals 1 over 2 ln of y. Now, if you look at the region R in the graph, from 0 to 1, the function has nothing to do with the base, with R. So from 0 to 1, from 0 to 1, the function has nothing to do again with the region. The function starts from y equals 1 and goes all the way up to what? E to the power of 2. Okay? So this business over here, okay, has nothing to do with the function. So it's constant, right? So the volume here is going to be 1, right? So the volume will be 1 plus, right, the integral from, now we will start from 1 all the way to e squared, okay, of what? Now, we need to find the side measure of the cross section, which is going to be a square. So we are looking for this measure, okay, because the cross sections are squares. So this measure here is given by 1 minus the function in terms of y, which is 1 over 2 times ln of y. This is the length of the side of each cross section. Okay? So this is going to be what? Let's go back to blue. 1 minus half ln of y all squared. Why did I write squared? Because the cross sections are squares. Okay, so the formula is the integral of s squared dy. That would be the answer of part C. Moving on to question 3. Question 3 says, let R be the shaded region in the first quadrant enclosed by the y-axis and the graph of sine and cosine. Find the volume of the solid. Which solid? Whose bases are and whose cross sections are cut by planes perpendicular to the x-axis are squares. So we don't need to isolate x here. Okay, the cross sections are perpendicular to the x-axis, but we need to find the intersection points. Okay, to know at which x value we are going to stop. We will go from 0. Look, the volume goes from 0 to which number we need to find out. How do we find out? By setting the two functions equal to each other. Okay, which angle in the first quadrant has sine and cosine to be equal? It's pi over 4, 45 degrees. So x equals pi over 4. So we will go from 0 to pi over 4. Now, the upper one is cos of x minus the lower one is sine of x. This is the side measure of this cross section. Okay, but because it's the cross sections are squares, we must raise it to a power of 2 dx, because it's perpendicular to the x-axis. Now, how do we integrate this integral? How do we evaluate this integral without using the calculator? Well, we know that if we have a minus or plus b all squared, if this is a squared plus or minus 2ab plus b squared. How about we use this expansion in this integral? Let's do that. So this is going to be v equals the integral from 0 to pi over 4 cos squared of x minus 2 sine of x cos of x plus sine squared of x dx. We know that sine squared of theta plus cos squared of theta equals 1, or sine squared of x plus cos squared of x equals 1. So we can replace sine squared, cos squared, together we can replace them with 1. So the volume now is the integral from 0 to pi over 4 of 1 minus 2 sine of x cos of x dx. Now, let's distribute the integral. So it's the integral from 0 to pi over 4 of 1 dx. I just gave the integral to the 1 minus the integral of 2 sine of x cos of x dx from 0 to pi over 4. Now, the first part of this integral, the first integral is straightforward. The integral of 1 is x. Now, the integral of 2 sine of x cos of x requires the u substitution. Requires what? The u substitution. So we will assume that u equals sine of x, du equals cos of x dx. We will divide by cos of x by cos of x. Right? So we can now go back to the integral. The integral v equals the integral from 0 to pi over 4 1 dx minus the integral of 2. Instead of sine of x, let's write u. Keep cos of x. Now replace dx with what? du over cos of x. Now we can see that cos will get cancelled. Now we can integrate. So the volume equals, what's the integral of 1? It's x evaluated from 0 to pi over 4 minus 2. What's the integral of u du? It's u to the power of 2 over 2. I'm not going to write evaluated from 0 to pi over 4 now, because I need to replace u back with sine of x. So the volume equals, this one will be what? Pi over 4 minus 0. I substituted upper minus lower. And this one, I cancel 2 with 2. And I will replace u with sine of x. Originally it was sine of x. Okay? But there is squared. This is evaluated from 0 to pi over 4. Now if you evaluate this one, the volume will be, this is pi over 4 minus sine squared of pi over 4 minus sine squared of 0, which will be pi over 4 minus 1 over 2. This is the volume, pi over 4 minus 1 over 2. I know this was quite long, but I'm doing it without a calculator, as I did not see a calculator icon next to the question. Okay, I don't want this video to be longer, so I'll stop here and complete the questions in other videos. Good luck.